Hi, this is Alex from devstories.eu, Snowflake and Snowpark Python, episode 11 of 17. How do you run custom Python string parsing logic across billions of rows without moving the data? The answer lies in creating Scalar UDFs, or user-defined functions. Standard SQL functions cover most everyday data transformations. When standard SQL fails, Python UDFs step in seamlessly. If you are dealing with heavily customized rules, like writing a complex regular expression to parse messy email addresses, pure SQL quickly becomes unreadable or impossible. Scalar UDFs solve this problem by letting you write plain Python logic and execute it natively inside the Snowflake compute engine. A scalar function simply processes one input row and returns exactly one output value. To deploy your Python code, you use Snowpark to register the function. If you only need the logic for your current script, you create an anonymous UDF. The easiest way to accomplish this is to use the @UDF decorator. First, you write a standard Python function. Let us call it extract email domain. Inside it, you use the standard Python regex module to parse the text string and return the matched domain. Just above the function definition, you place the @UDF decorator. When your script executes, Snowpark automatically serializes this Python function, pushes it to the server, and returns a reference to a UDF object. You can now pass this object into your data frame column operations, applying your custom parser across massive tables as if it were a native database feature. Alternatively, you can skip the decorator and pass your Python function explicitly into the session.udf.register method. Both methods create a temporary object in the database engine. The moment your Snowpark session closes, the anonymous UDF is dropped entirely. This is where it gets interesting. If your new parsing logic is valuable, you probably want to share it with other users or make it available to downstream SQL pipelines. To achieve this, you create a named permanent UDF. Using the same register method, you add an isPermanent flag set to true and provide a string value for the name parameter. This name dictates how the function will be called in the database. When you make a UDF permanent, Snowflake needs a physical place to persist your Python code so it remains available long after your session disconnects. Because of this, you must also provide a stage location parameter. This points to an existing internal Snowflake stage. Snowpark will upload and safely store the compiled Python files directly into that stage. Once the registration finishes, anyone with the correct database permissions can call your custom Python logic right from a standard SQL query. When creating any UDF, Snowpark typically relies on Python type hints to understand what data types the function accepts and returns. If your function expects a string and returns a string, you add those standard type hints to the Python definition, and Snowpark maps them to the equivalent Snowflake data types automatically. The true power of the Scalar UDF is not just the ability to write Python, but the ability to execute that Python within the distributed memory of the database engine, completely eliminating the network latency of pulling data out for processing. That's all for this one. Thanks for listening and keep building.